Welcome, everybody. My name is Brent Phillips, and I'm the organizer behind the Humanitarian AI Meetup groups, and we have about 15 Meetup groups around the world. And I'm also the new organizer of the Princeton School of AI Meetup group. I kind of took over, and I'm helping to kind of relaunch the group, and we have, I think, 4 co-organizers now, so it's super cool. But it's interesting because the Humanitarian AI Meetup group, we try to interface humanitarian actors with AI developers and others, and just talk about humanitarian applications of artificial intelligence and bring people together and work on volunteer projects. And one of the things I noticed is that it's kind of helpful to learn new skills as well. So it's kind of cool to team up with the Princeton School of AI Meetup group and kind of bring them into the dialogue and bring us into their dialogue. And today we're kind of launching in a collaborative event where we talk about voice training and voice training data sets. And that's because one of the volunteer projects we're working on with the Humanitarian AI Meetup groups is to think about how humanitarian actors can, ask Siri or Alexa, hey, who's working in northern Syria? How do I plan a relief operation? Who has the capacity on the ground to deliver aid to a specific area and that sort of thing. And technically, it's a really hard challenge. And one of the critical things that needs to be done behind the scenes is to create training data sets to think about, how do you actually train the AI application to, train Siri or Alexa to answer queries posed by humanitarian actors. So it's a very interesting subject, and which I don't know a lot about in terms of training data sets and how do you format them and how do they look and what's needed. And we're lucky enough to have an expert here, Timo Baumann. He's from the University of Hamburg, and he's going to talk about his work on the Wikipedia corpus, the spoken corpus of Wikipedia. And, maybe we can learn something from you and chat a little bit about, how do we apply what you've worked on to what we're hoping to work on, and what can we take away that might be useful. So welcome, Timo. I'll let you introduce yourself.
Yeah, thanks, Brent, for organizing this. Yeah, my name's Timo Baumann. I think at present I'm not quite a professor. I'm substituting for a professor in machine learning in Hamburg here. I'm supposed not to say that I'm a professor. I think I have to do that. It's verbatim written in my contract to be safe. Yeah. So I do that, and I work on speech and language research. Currently at Hamburg, before that at CMU and in Potsdam and Bielefeld, a bunch of German places. Yeah, and I work on 2 things that I think are really spot on to what you were talking about, Brent. One is a spoken dialogue system. So basically, not quite Alexa, but systems like Alexa, and there a particular aspect in there that in itself I find quite interesting to make for more natural interactions, but I think which are not necessarily the most important aspect in building humanitarian AI systems. Another part of my work is building open source speech corpora, and this is more directly involved to what you guys are currently planning. And I was, well, basically, I guess, the driving force, or I had the idea and followed through with it, to turn the spoken Wikipedia into a corpus. So the spoken Wikipedia, I don't know if you've heard about that, but there are many people actually reading out Wikipedia articles. For example, for people who have hearing, who have problems with eyesight, or people like, who don't want to read but would rather listen. Like, for example, there are a lot of history articles, and these are being read out, and then you can actually consume them in their oral form.
What's the scope of the project? Just to interrupt, like, how many? It's so fascinating, and how many entries are there, and how, I guess people can. It's an interface that they can connect to.
Yeah. So first, I want to say I'm not the inventor of the spoken Wikipedia, right? So that's not me. But the spoken Wikipedia, I think there's a bunch of people. But I mean, it's you're never gonna make it, right? There's so many Wikipedia articles. The coverage of the spoken Wikipedia corpus, I think it's in our paper. I would have to look at the numbers. You know, it's like 1 or 2 or so % of the articles marked as outstanding or good or something. So it's literally like none of the articles, and also an outdated version of none articles. But nevertheless, right? If you can't read, then that's much better than nothing. And the coverage differs between languages. So we looked at that for German, English, and Dutch. And apparently, in the Netherlands, they had kind of like a drive towards having a good coverage, but they only read out kind of like the abstract, the first part of the article, very often. And Germans are thorough, so there are articles which take like 2 or 3 hours to read, and they actually read through that, some town in somewhere rural Germany. So there's a very good mixture of pretty much everything in there. And like for me as a speech researcher, what's really interesting about it is that it's not necessarily experts speaking this, but it's people out there who happen to want to read out articles. They're doing the best they can, but it's not necessarily perfect. So I posted a link here, which has some information on it.
Just to break in any sort of like metadata, when you have a range of speakers reading articles, do you add any sort of, this person's a male or female and the age group, or sort of any sort of extra data that you tag onto that?
I add, or we actually grab everything from Wikipedia that we can. So you would think that Wikipedia looks like a database, right, to the outside observer, but it's not a database. It's just a loose mess of stuff. So we get everything that we can about the speakers. However, there's no structured information on whether they're male or female. I think for the German listeners, for the German speakers, sorry, I went through them and kind of like hand annotated my guess of their gender, right? And this is then binary, which already is wrong, and maybe I mishear every now and then. What we also did was do a comparison of the voices, and we were more thorough with the metadata there. So I can, that's why I was saying listener earlier. I know, who prefers which voice over which other voice, and then about those listeners, I know like all sorts of metadata about them. But that's kind of like the data that I collected, actually. So anyway, there's this spoken Wikipedia. It's a nice resource. It's also actually cool for Wikipedia itself. However, it's not very accessible, and it's not pushed in any way. I think it was pushed some 5 or 10 years ago, a little bit, but then they quickly noticed that it's a lost cause, basically, in terms of coverage and remaining up to date. And it's also like everybody thinks that speech technology will fix this for them, which may or may not be true, and probably still isn't true, because listening to long stretches of read out speech read out by a machine is super annoying, because they have no grasp at all of what's going on in the text that they're reading out, where to put emphasis and so on.
Go ahead. Oh, I just had one quick question. I hope you don't mind me popping in, but just when you talk about synthetic data, it just sounds kind of crazy. But imagine if you have a machine, like I guess Wikipedia will go to just default to people can just have the article read to them, with the computerized voice, and you could actually create a synthetic readings. Like you could have 20 articles and just have the computer read it, and then put that into your data set. And it seems kind of crazy to have a training data set read by a computer, but in terms of the way people, since the computer is actually just reading how something is written in a human originated stream, would that help for training?
No.
No. Okay.
No, it would be circular, right? You don't learn anything. This is kind of like using a rule-based system to learn a database system, or to train a database system, or produce data for a database system. A database system would only learn the rules, right? And if your rules are really good, then there is no need for a database system. If your rules aren't good, well, then you don't want the training data. So no. Sorry, that wouldn't help. There actually are 1 or 2 accounts that in the spoken Wikipedia, right, in the community, that posted really terrible TTS data, and we ripped those out because they are not helpful. What we did, though, was as a first attempt, or like a first use of this material, once we turned it into a corpus, was to enable people to actually browse through these audio files. Right? In Wikipedia, basically all you got was this little slider for 1 or 2 hours of audio. So basically 1 pixel would be 20 minutes, and you wouldn't be able to browse through this, right? So what we wanted was to make a connection between the textual lexical entry, like the article on Wikipedia, and the audio file, as much of it as possible. And then you can say, okay, take me to paragraph 9, or you can actually search in it, right? Which we didn't do in that particular application, but we actually mixed text-to-speech technology in there because they don't read out the table of contents because it's automatically created. But it's convenient to have a table of contents, so we simply kind of like replaced the missing speech from a human with TTS there. Of course, you do notice the difference, right? And we didn't try to conceal this, but it's still very, very useful, and much more useful than having just the slider, right? I think we assessed that by asking weird questions about, I don't know, some mountain in Bavaria, actually Bavaria again. And then literally no one would find this information without being allowed to browse through the article. But with having the ability to browse through this, it's actually very, very easy to find. Yeah, so that's what we did, and to get us there is actually not super easy. So first thing is kind of like, okay, so how much data is it? Well, hard to say, because you first have to browse the textual articles and then download the audio files, and then in the end you'll find that, well, at the time of writing this, there were some 400 or 350 or so German hours for German, similar for English, and some 200 for Dutch. So it's substantial amounts of speech, right? So that's why I, as a speech researcher, yeah, it's large, right? It includes something like 40 hours of silence from all sorts of different microphones in all sorts of recording setups, right? Because even as I'm talking now, I'm making short pauses every now and then, and this adds up to 40 hours in total, which I haven't looked at yet, but it's super exciting. I still want to look at that.
Did you break, just speaking about that, did you break the clips apart? So you downloaded it, which was a massive task, and then you reassembled the clips into a file. But did you edit the clips to take away some of the empty spaces?
So we download the original, whatever it is, I don't know. It's not MP3 files, but it's like open source MP3 files. Some of them may actually be MP3 files. I never looked. And then we converted to just plain wave audio, right? So uncompressed, it's a bit larger, but it doesn't really matter. And then in the end, you end up with something like a few gigabytes, like I think here 12 for English and 11 for German. And this is our original release. The more recent is moved. So you get a lot of data, but handleable, I would say. Yes, it is large. Yes, it will take overnight to download. But it's all right, right? It's not huge in that sense. So we take the original audio file, and in Wikipedia, they always say which article revision this was based on. Well, they don't always say that, but they often say that, and that's ideal. Or they say when it, like what dates revision it was based on, or at least we have timestamps of when this file was created, and then we can guess that it was, based on a text file that was slightly before a text version. And this works like 99% of the time, and then we actually get that revision off of the written Wikipedia, right? I think we get the most recent one, which points us to the spoken version, and the spoken version points us to the one that was written, that was read. Sorry, the written version that was read. And of course, there is no 100% match between the two, because they don't read out the table of contents. Well, that's easy. Also, they don't read out complex tables, because reading out tables is really difficult. They don't read out image captions. So a lot of things that they don't read out, a lot of other things that they do read out, like descriptions of a table, although they're not supposed to. They describe images every now and then that they see, well, where they are rendered on screen, which need not necessarily be where they are placed in the HTML, well, in the wiki text stuff.
Is that challenging to work with? Is that hard to work with, like all the extra bits that are irrelevant?
Well, it means that instead of being able to, well, we don't know what's being spoken, but we have a very good intuition of what people are talking about in these files, right? So basically, the task in the end is not directly aligning the text and the audio. So alignment is the process of saying, okay, this is spoken there. But it's a more, we call it robust alignment task, right? So you have speech that doesn't go with any of the text. We have text that doesn't go with any of the speech. Bad luck, but roughly, like by and large, they do talk about the stuff that is in the article. At least they're supposed to. They're always prefixing it with some header.
How do you find the reading style? I mean, because we've got some data, and you ask people to read something in natural voice, but they still feel this overwhelming need and desire to perform.
Yeah, well, I don't judge them, right?
Okay. I'm just curious.
Yeah, but you're right. So by and large, I would say these people are investing time, right? And they don't have to do it. I would always guess that whoever is on Wikipedia, they're probably doing the best they can. We have this one guy who speaks something like 40 hours. Wow. And this is kind of like the final produced product, right? So, you don't want to know how many hours of work went into that. I probably don't want to meet that person, or from the distance maybe. But it seems like an odd hobby. Right? Yeah. But I guess this is what Wikipedia actually lives off of. Also, when I said earlier, these are not professionals, this is actually not true. It turns out that a lot of the readers really sound professionals, and from skimming through the profiles, at least some of them are professional readers. So like audiobook readers and so on. So they know their business, and because that's something that they do well, they also do it in their free time because it doesn't cost them any extra, I guess. So a lot of the reading is really good. A lot of it, or some of it, is awkward. So I could point you to some examples, but let's not go into those details. I'm more familiar with the German voices. So there are good readers and bad readers. That's one way that I would, as a phonetician, like to, as a phonetician, I wouldn't want to say that, but there are good readers and bad readers, right? Yeah. Then also what's kind of weird is there's wrong style, right? As you were pointing to. Like if you talk in a too enthusiastic way about Wikipedia articles, then that's wrong, in my opinion, right? There's also the guy who's really bored.
How does that impact training, like down the road, in terms of the style? Just out of curiosity, what sort of problems can arise from?
So I like the theoretical answer to this would be all sorts of problems. The spoken Wikipedia, like training off of that, still yields the best open source models for German, at least, and it's always part of the open source English models as well. People use it widely because I mean there are really odd kids in there, but you know what's a good style? I mean, that's what everybody does, right? I guess, you know, it's kind of like the consensus across everyone that equals good style, I guess. Right. There are some non-native voices in there also. Like this one guy where I really think he's just trying to learn to read out in German. People don't like that in our you know, reading style classification. Yeah, but hard to say whether that's useful or not.
That's something I could not comprehend doing, recording myself in a second language.
But it's, I mean, in the end, he's probably improving open, like, you know, through some hoops that he didn't intend. He's improving speech recognition technology for a lot of Slavic languages, like speakers of a bunch of Slavic languages that speak German. He's going to improve that just by being in there, you know, and having been thorough, and you know, he's also quite, you know, he stuck to it.
I'm talking.
Hey, just, okay,
sorry.
Go ahead.
I was saying, talking of which, I mean, do you think you have many readers who have really strong accents as well? I mean, say for example, you know, in Germany, someone from Lower Bavaria, you know, and yeah, or do you think people are making an effort to speak in a more standard way?
I think mostly they're speaking High German. There are a few. I mean, I don't like. I really only listened to. So it's not many speakers, right? It's 200 or 300 or so for German, maybe for English, and it will be more now, right? What I'm talking about now is like 3 or 4 years old, and like my comprehension of the data. But it's still an ongoing project, right? This is still being collected. So there is a bunch of Austrian, a bunch of Swiss people in there, speaking Swiss German and Austrian German. And yes, you do notice different dialects. I think I didn't notice, I don't remember a strong Bavarian accent. I do remember a strong, I think it's more Saxony than Thuringia or whatever it's called. So some Saxonian accent. But it's not super strong. And like there is no annotation for this, unfortunately.
Okay.
Speaking of annotation,
it's predominantly male, right? That's also a disadvantage.
Sure.
Speaking of annotation, you know, in storage, like how did you so how do you piece? So you collected the data. How does it look pieced together in your data set, and how are you storing it, and what about the annotation and things like that, and like the storage, like what does the database look like if you clicked on it or downloaded it, or what file is it, and that sort of thing?
Yeah. So I don't know if I can share this, but the link that I sent down there's actually an image of this where it says 500 hours of audio. So this is kind of like a structural breakdown. So we do two things. One is we do not alter at all the HTML that we get out of Wikipedia. Instead, we add additional tags. And also we don't change the, in XML, maybe in XML voice languages, or at least in SGML languages, it's called the C data. So like, the data that is actually, not in tags. So whatever white space and line breaks are in the original article, we don't change that at all. All we do is add more tags. And if you weed out all our tags, you have the HTML as it was. And then in this 500 hours of audio example, we would add tags, including around the white space and around the tokens that we find, including sentence end markers. Now, not all of these will then, in the end, get a timing, right? Because punctuation is not spoken in that sense, so they don't get timing. But here, our tokens will be normalized into something like 500 hours of audio, and these then will have timing information associated. We're being a bit conservative there, so we are trying to, or we're not trying to align everything, right? As I mentioned previously, it's not possible because not everything that is written is spoken, not everything that is spoken is written. And also we want to make sure that when we provide a time alignment, it should be right. So we're kind of like being on the conservative side there. But that's basically the format. There's probably also a link here somewhere to the language specification, yes, the schema.
And this is a dumb question, but what happens if you if I clicked on that link? You know, do I have to worry about my computer being overloaded, or like what happens when you click on that?
Which link?
Or I guess the link to the, like if I found the actual data set, you know, how does one even prep to open that?
Okay, it's not particularly difficult, right? I think so. You don't want to click on the data that's provided from this page, but like where it says download current release. Wow, 2017, so 4 years old. It will take you to some part of the University of Hamburg. Is that moderately in English? Well, Beschreibung, Metadaten. There's an English version. Nice. Okay. So, you know, you click on attached files, and there's always 2 parts. There is, say, you know, for NL, for Dutch, there's NL with audio and just NL. And whatever is TXZ for a file ending. I don't know. This is kind of like some weirdly encoded tar file, right?
Because I hovered over that and the other day, and I was worrying about my poor computer, like, you know, audio files. That's got to be a large set of files.
Exactly. The one with audio files is probably a bunch of gigabytes. The one that is just the text, just the XML, is just a bunch of megabytes. Right? I just downloaded it. It's still not broken. Yeah. Now, like if I look at the Dutch version, that would be fun. I wouldn't understand a word, right? So nope. Let me go back. I'll click on nerd. There was nerd here just a second ago. And then there's a bunch of files, right? There is, and like each of these directories contains the same set of files. I think the first is the one that is interesting at first is info.json, that is extracted by our scraping script, which where it kind of like contains all the data that it finds from these lists that the spoken Wikipedia is built off of. And then you have wiki XML, wiki text, and wiki HTML. It's kind of like 3 versions of the same file of this article revision in the wiki text format. Wiki.text. It's wiki text, right? The stuff that you could edit on Wikipedia. Then an HTML rendering as we get it out of the Wikipedia API, and an XML version. I don't quite know why we have all 3, but you know, better safe than sorry.
Let's say you're going to do some training with all that. What's the standard communication? How does the, you know, when you want to use that, how does the computer interact with that? And you know,
yes.
Just out of curiosity.
Yeah. No, you're right. The computer will. No, that's the wrong link that I sent you. That's the link that I sent you previously. That doesn't help us, but this one will help. Might help. Probably not help. Let's see. So there's software to go with this, right? So these files that I mentioned didn't come out of nowhere, but there's also software mess by now that helps you to do all of this, right? This alignment process is actually quite slow. Of taking, well, I guess downloading the Wikipedia is not what you should be worried about, but then doing the forced alignment of the text to the audio, that is moderately slow. And then we run a second stage where we actually look at the phonemization of each, well, pause, probably roughly sentential units, right? And then we look at how should they be phonemized, and then can we actually, get phoneme by phoneme timings for these. Phonemes are kind of like individual speech sounds like ah and k. All of this is kind of like the slow part that you want to parallelize if you can. I guess, if today I was doing this, not 5 or 6 years ago, then I would probably just buy one large computer. Back then you'd have a bunch of, by today's standard, small computers. So there's kind of like, when I look at this, job runner and stuff, this is kind of like tedious stuff that you need to distribute the work.
Did you have a lot of volunteers that helped with the annotation and just doing that? Was that most of you behind the scenes doing? It's a lot of work to pull it all together and annotate it and.
So there is no real annotation in that sense, right? There's the alignment that is automatically performed, and then there's some quality control, which was done by a bunch of students. Basically saying, how correct are these alignments actually that we automatically derive, and that was 1 or 2 students that I worked with at the time. And then there's of course like the software stack, which is again a bunch of students and me and a colleague who did all of this.
Do you see? You spoke about what you did 5 years ago and what you would do differently now. Have training data sets evolved? Like what's the state of the art in terms of like a training audio data set, in terms of, how it's generated or how it's put out there and whatnot?
So they have evolved, but they have evolved since, I guess, longer than all of us have been around. And I'm still working with data from the 90s that is perfect, right? Which is really, really good. They have awkward formats, but they've thought out most of the problems back then. One particular problem that was often left out was white space, right? And this is kind of like one thing that we were more thorough than anybody else in. And we really focused on being able to say, well, weed out our tags and you're left with the original text. And this actually works, right? There is a script in this the software stack that I sent you, which kind of like tries this for each and every file as quality control. So this is really good because a lot of corpora will kind of change your data along the way. And that sounds like it's a good idea, but it always messes up, right? Yeah, we always keep the link to the original data. This is also why we point to the original long audio file. In this, you were asking about how can I use this for training? For example, training a speech recognizer. There is probably a script somewhere, I guess in util is where I would look, but I don't know. No, not in util. Maybe in a liner. Somewhere in a liner. Well, there is a way of getting, small snippets of texts and audio files. That's actually what you need if you want to train an ASL system. However, that's not what we're providing. We're providing the kind of like vanilla version from the corpus, and then you can derive this based on our format.
Interesting. Hey, I've got a question. So, for example, what we're interested in doing is there's sector codes. So humanitarian organizations, there's a whole standardization movement where governments are mandating aid organizations to report what they're doing using a standard, an XML standard of report it using specific information fields. And there's one information fields that's sectors, and there's a whole code list to deal with sector codes. And there's probably 800 sector codes, but it's kind of cool because they're very granular. So when you're analyzing queries, for example, I have a code here, emergency response, I don't know, food, non-food related items and food related assistance or emergency health services support. So those are different code breakouts. So it helps you to sort of find out what the intent of the query is, using this as a tool. So the idea is just to read, maybe the code, 72020 emergency health services support, and then maybe asking the volunteers to form a question around that. So maybe like have 3 parts of the data set. But what let's say you were being assigned to this project to take 800 coded descriptions and create a data set out of that. Like what are the first things that cross your mind in terms of what questions arise and where would you start and that sort of thing?
Right. Yeah. That's so. I think you mentioned this is one of the emails, that this is actually what you're planning to do, right? And I think it's a little bit different from what I was describing here, right? I here was describing the task of taking some data off the web and turning it into a corpus that you can use for speech research, basically, or speech technology research. I think what you're describing is data collections, right? And what I'm like, and like one question that I had is, would people actually say these codes? And will they then, and this was a topic earlier by Nick, will they then act them out? Will they say things differently when it's, I don't know, they're talking about fire than about flooding? Will they sound different? I don't know. Or will they sound the same? And should they sound different because audio conditions would be different in application, right? Also, I don't know what the application is precisely. Are you interested in?
That's a good question. The whole humanitarian field, we're still at an early stage. And the idea of training, again, digital assistants, how to answer queries is still a bit of a mystery in terms of the engineering. And there's so much data out there, and it kind of helps to just start creating some training data sets, even if they're not perfect, just to sort of catalyze more efforts. And this is something that might be useful, having all 800 of these codes and descriptions turned into a training data set. It might not, depending upon how the processing is done, but it seems like an interesting exercise to help get some questions on the table.
Well, I guess, so what do you want to train to? Do you want to train the speech recognition part, or do you want to train the intent recognition part?
I think both. I think the speech recognition and the intentions. And, I think the technology has advanced so far, I'm sure it could pick apart what a person is asking, and then to be able to break it down, the intention, maybe having these sector codes, that helps to understand the intention of the question. It could be one of the tools in a quiver of different tools to help understand what a person is asking, and then help to strategize, well, what data should I seek out to answer that question? So there might be some utility there. The idea with the project was just to sort of, again, like crowdsource. Like we have, 6 people on the call. If we all read out 10 codes each, you get 60 codes, 60 entries. And, what could that look like? And how do we get started with the project? And it's just a fascinating challenge. And, your experiences. So just hearing what you did on your, a different project is still very useful. And, the challenges that arose for you.
So I think so there are multiple things in there, right? Typically in like any larger like speech and NLP system, the components will be trained on different sets of data. Typically, right? You wouldn't train your humanitarian AI's data set, like whatever you actually want to do with these codes, right? I still haven't quite found out. But when you want to recognize them, you wouldn't do that only on speech data where you read out these codes. Because face it, I mean, you're going to use words that are roughly similar, or digits. I heard those, and I've heard people use digits and phone numbers, right? So why not use any, and also, like, the phones that you see in digits are in, like, all over the place, right? Basically, there's just 40 or so phonemes that you have roughly per language. Some might need a few more, some have other phenomena like tone that you need to deal with, and most likely you'll be more happy just using a speech recognizer, period, turning that into some textual form. And there it starts, right? Being able to figure out what kinds of texts to expect is quite important. So the language model is actually quite important.
Thank you. Yeah, that's a great input.
I have a poorly formed thought, but maybe it's something worth looking into. As you're sort of speaking about all these codes and these kind of quite granular terms for all these different categories of activity, it sort of reminds, I mean, I've got a background in healthcare, and it reminds me of how, in some countries you have very specific codes for medical procedures, examinations. And just given, there's lots of activity in mining health records, I wonder if there's some kind of analogous work you might be able to get some inspiration from.
Yeah, it's true, there is.
And, it sounds very similar,
No, this is great. Yeah, it's interesting because there's, maybe 2,000 humanitarian organizations that are reporting their activities using the standard. So you could actually take that code and cross-reference it to an activity that was carried out, related to that, and maybe those sort of relationships could help inform the, the intention, trying to understand the intention, to break down intentions of a query. Okay. So it's sort of a, a different, and then you have all the different, the key and value pairs that this open data standard uses that can help to break apart queries. So you're right. They can all help in different ways.
Yeah, it just makes me think of health data records and data record mining sort of stuff. Yeah.
Which is typically written data, right? If you're unlucky, it's going to be basically handwriting recognition.
Yeah,
for doctors is kind of like
dreadful.
Yeah, exactly. Like the ultimate challenge. Because I think also for insurance reasons, right? You don't, like, as a doctor, you want to be able to say, no, I meant the opposite. So that's also, I mean, there's a purposeful challenge in there, I guess.
So what are you working on next? What's exciting on your radar?
On my radar, currently, I'm actually looking at dubbing. So it was a question about teletyping embedded in TV. This is interesting. But we're presently we're making or we're working on translation that is best, or is as good as it can be, given that it needs to be spoken lip synchronously. And while we're at it, we might just change the lips around a little bit as well. So this gives us additional degree of freedom. This is something that I'm working on at present. And another thing which kind of takes me back to dialogue systems is looking, and this is inspired by the pandemic, looking at students talking to each other via something like meet.google.com, but in our case, it's Big Blue Button. We have kind of added this speech recognition technology to a Big Blue Button, so you get basically free subtitles in your Big Blue Button conversations. And I don't know if you've run classes via Big Blue Button, but you put people in breakout rooms and you have no clue what's going on, right? And you can go to one room or two rooms or three rooms, but you're never going to make it to, I don't know, 20 rooms. So getting a high level view of what's going on in there would be really interesting. And also, like, I'm personally interested in multi-party conversations. And all of this via Big Blue Button is super convenient because we have different audio channels, we have video recorded along with it, and that's an upcoming project as well that I'm working on, which is kind of
fascinating. That you have humanitarian organizations around a conference table, and you might have 10 people haggling over what to do and what aid to provide and how and that sort of thing. And it's it's interesting.
So one of the things that we did was attempting meeting summarization and linking to relevant entities. In our case, linking the slides from the professor with the ongoing conversation. Well, the lecture, I guess, in that case, and making things linkable, right? So you get this transcript of the conversation, and you can click on stuff, and it'll take you to the slide. So that's actually quite cool. But this was a student project during the pandemic, which was really nice and had really cool results. And we'll see how we can actually, turn this into a more researchy project soon.
It's interesting. We started a podcast series mainly during the COVID crisis, just because it makes it easier to still continue to have discussions and interview people and things like that. And lately we've been trying to ask this question at the end, in the future, what sort of fantastic futuristic application would you love to see developed? But I love what you just said. That would be a great answer to that question, of just be able to follow around all the questions and simultaneously be able to have information show up on the screen relevant to what people are talking about at that moment in a group.
Mm-hmm. Yeah, I find that interesting. Now you add in dubbing, and I can speak whatever language here, but my lips will still look like I'm speaking English, and I'll be speaking English to you. And I think that can be a great aid in humanitarian applications as well, because you have people from all over the place, experts in all languages, and certainly quite a number of difficulties in understanding each other. Now, there's a reason why we switch on video in these, and John and Douglas, this is fine, right? But in general, there is a reason why people have video in these calls, right? Because it's easier to understand each other, to monitor each other. And so this dubbing technology, ultimately, I'd like to see this applied in these interactive sections as well.
Thank you so much for all that, sharing so
Absolutely.
much. And we're reaching our hour, but I just wanted to thank you, and thanks to all of you for tuning in. And that's what we're trying to do, is just really.
It's okay, Timo. I'm still here. It just allows me to yawn without embarrassing.
Oh yeah. Sorry for that.
John, do you just want to give, just for a moment or two, just share what you're working on?
Yes, it's the IATA dataset. It's 8,000 XML files that are being produced by the aid agencies that summarize the activities they're engaged in, and each of those data files, the 8,000, is then split into the set of activities, and it can be 2 or 3 up to several hundred within each of those data files, and then you've got results, transaction, and it spreads out. So there's some of these are quite small, some of them are really quite big data files, and I'm trying to slot this into a Google Firestore database, which is a database that's very restrictive on the form of the data that it will accept, that it will, it's limited in the size of a document that you can put in. So you have to take these original XMLs and convert them into a hierarchical structure of documents, and do it in such a way that you keep a consistent structure across data that breaks out in quite a variety of ways. And you're trying to split it up in such a way that when it's indexed, it will pull suitably sized blocks of data out, or write data in suitably large blocks that you don't have to do too many writes to get it in or out. So actually, what sounds like a very straightforward task take a bunch of 8,000 hierarchical files and drop them into a database, it ought to be a morning's work. But when you try to marry this with the arbitrary constraints, arbitrary in inverted commas, the constraints that the Firestore database sets you, it then becomes quite a problem to do it in a fashion that is both efficient for Firestore and efficient for the person utilizing that data. And at this point, I think I've got an answer, and I'm just trying to find a little gap in my timetable to just go and splurge all the data in there. So we're pretty much there.
It's amazing.
What the stuff consists of is a mixture of categorical data and text fields. So there are the sets of values of the type that Brent was describing earlier. There are also places where people have dropped into results either some financial stats or very simple stats, or several hundred, maybe 1,000 or 2 words of description of a result. Mm-hmm. And so in terms of what Brent is trying to do, what we will, I'm at the final stage of dropping the data into the database. So you'll end up with small number of thousand of descriptions of organizations and tens of thousands of descriptions of activities. And then those activities each need to be indexed either on the categorical data or some semantic extraction of the pieces of text that are in there, so that that material can then be matched up to appropriate indexes to be queried in whatever form. So I hope I'm in the final stages of getting that data just dropped into this Firestore database to be able to then open it up for folks to go, yeah, well, you could have done that better.
Yeah, so we're thinking about ways to train, like, how do we train these queries that are querying against this database? And so how do we train them, and how do we test them, and how do we optimize the responses? So that's sort of where this project is starting. This, voice dataset project is just, let's just take a stab at something and then start creating more data sets that can help with that training when we're ready to do that. So any thoughts on that?
I wonder why it has to be spoken data. I think this is kind of like the first introduction of spoken data into the project, right? And I'm wondering how queries on humanitarian data that are spoken versus written, right? So here versus here, how they differ as compared to any query going to Google via the phone or via keyboard.
Yeah,
so I'm kind of like making myself useless here, right? And by saying these things, but basically, I don't quite know. I mean, it's always worthwhile to ponder the specific content, and I mean, this is really exciting data, John, that you were talking about, because it's semi-structured, right? There's a lot of structure there, although it's not structure in the sense of a database. Kind of very similar to Wikipedia data, actually.
I was thinking of maybe training and testing in terms of matching a query from the field versus a query that we collected, and testing to see maybe if if the machine could replicate that, or how well does it match what was actually said versus.
I mean, the one thing that I would say is that quality is going to be a massive thing, and it's not just having enough single speech samples of what you're looking for, but having them in very, very qualities, especially data coming in from the field is going to suffer in terms of bad phone connections, you know, someone answering something, holding their phone here, there, you know, there's a variety of different ways you can interface and induce more noise into, or just a different form of noise into a speech sample. And then I think the other side of it is also something that I see a lot, I think now in health data, where people use text and they use speech and then they use transcripts of that to infer a health state, but they say, oh, you know, yeah, we'll pay a company and we'll get these brilliant transcripts done, and yeah, using speech we can predict health, you know, at 80%. You go, no, you can't, you didn't use speech at all. You know, but I guess my point is more that when you start to then put ASR in a loop in these situations, the ASR will always have an error, and there's not much you can do about that. But it's understanding different ASRs will make different errors, and I guess contextually where those errors are, to if they affect a success in your query, is, you know, another aspect to consider. If it's, you know, if it's getting your name wrong, but at the same time getting the, you know, location and the query, you know, humanitarian, you know, Syria, but getting someone's surname wrong or something that doesn't matter in terms of the query, that's not a bad thing. But obviously if it's getting the country name wrong, that's bad. So just no, that wasn't a good example, but maybe trying to give this idea of what I mean. It's which words it's making mistakes on can make a massive difference to what success, I guess, for your application.
Yeah, thank you, Timo, for your question, because it's such, I'd love to, like, you know, encourage people to question all the aspects of the project, because that's how we learn and think about it, and it's really inspiring. And thank you so much.
No, I also agree that it's good to, like, I like this holistic view, right, of saying I want to go from the speech to, you know, well, actually to the speech of the system answering, maybe if it's a dialogue system. However, I guess there are like intermediate levels of representation and of data that one wants to consider as well. So you know, I think both are important. I guess when you were talking about, you know, inferring health status from what people say, it doesn't make sense, right? I mean, it's how they say it, right? And that's how I hear, whether it's you know, aspects of the voice, about, you know, the heart. Probably I can probably measure heartbeat if I listen sufficiently long, and so on. However, as I understand it, you're mostly interested in the content, right? And that's basically what falls out of ASR. So at least at the moment, right? Maybe eventually you want to sort queries by urgency, right? If you pass queries on to a human operator or to a system, then urgency, people will trick you into saying the words that they land at the top of your queue, but you want to infer it from the voice, which is much harder to trick.
That's a good point. And, you know, we'd love to have a list of queries that, you know, example queries, but exactly how do you get somebody to give you a query without kind of coaxing them? Like, you know, you don't want to prep them. You want it to be a query that's just from their own mind. But, you know, you can ruin your training database if you prompt people with how to say or what they should say or whatnot.
Well, I guess it must be the experts that would eventually use whatever system that you end up with, right? So it's always like you have this corpus from the 90s that I was referring to earlier. I think it was also recorded in Augsburg, the Verbmobil corpus. So anyway, it's kind of ancient, and also it's students talking to each other about business trips, right? And like in the 90s, students didn't fly; they didn't know how this works, right? So it's like what they're talking about is complete nonsense in my you know, today's view. They are talking about travel arrangements, and that may have been good back then. But I ignore all that part and use it for training in ASR, and it tells me the correct phoneme sequences, right? Now, I guess your situation might be different because figuring out phoneme sequences and turning that into words is largely not solved, but by and large, this works quite well, and there's lots of data for that, right? You can use the Wikipedia, you can use other open data collections. There's Wikimedia that collected data. Mozilla that collected data. There's VoxForge and so on. You can use all of those. It doesn't matter. Because more data here really is better data. And then I think focusing on the important bits.
See you, everybody. Sorry, I've got to duck out, but it was really nice to kind of meet you. And it was a really interesting discussion. So
thank you for tuning in.
Okay, see you later. Bye.
Thank you. Bye-bye.
And we are past the hour, so I do thank you for joining in. And any last words?
No, keep me posted, right? Sounds really interesting. Even if it's just the NLP stuff that you tackle, even John, if it's exciting stuff that you do with the semi-structured data, it sounds really interesting, right? And really useful, or really, I guess, moving the planet forward. That's what I like and research, right? If you were asking, can we do something to reduce word error rate by 1%? I wouldn't have accepted the call because I simply wouldn't care, right? But this is something that I care about. I don't know exactly what will move this forward, but it should move forward.
That's a great point. Thank you, Timo, and thank you all of you for joining in. And this brings our discussion to a close, I guess. That's how we like to close our podcast. So we always say that. But thanks again, all of you, for tuning in. And
thank you for the invite. Thanks, Timo. It was fascinating.
Thank you, guys.
Thank you.
Much. And thanks, Brent, for organizing this.
All right. I'm going to stop recording. Here we go. All right. Yay.